To stay updated, subscribe to TJ Academy.
In this video, we are going to discuss the concept of stationary and non-stationary series, including a Augmented Dickey Fuller test, means unit root test. First, we have to discuss what is the meaning of stationary series. There are three conditions. Number one, constant mean. Number two, constant variance. Number three, autocovariance should not depends on time. If these conditions or these features, means series has a constant means, if series has a constant variance and its autocovariance does not depends on time, it means series is stationary. It means the series is stationary. Then how can we detect that this series is stationary or non-stationary? There are three methods. Number one, graphical method. This is very much informal method, like we have to select series and view, make a line graph. So in this series we can see the value is increasing over time. So this is an informal method, and after look at the graph, we expect the series is non-stationary. This is the first method, but this is an informal method. Second one, autocorrelation function. For this, correlogram and OK. So this is the autocorrelation values, function values. If value of autocorrelation function will not die in one-fourth number of legs of the series, it means series is non-stationary, like this. In this series we can see leg 1, leg 2, leg 3, leg 4, there is autocorrelation, so we can expect the series is non-stationary. The third and most formal method is DF or Dickey and Fuller test. Dickey and Fuller test. Now we are going to understand the concept of Decay and Fuller. Here we consider an equation where yt is a dependent variable and y t minus 1 means 1 year lag value is the independent variable plus error term, and b is the coefficient of yt minus 1. So here if b is greater than 1, it means series will be explosive, because the lag value is increasing the next current value. So if every lag value will increase the current value, then ultimate result will be the explosive series. So this will not be the case in consideration. Number 2, if beta is less than 1, it means the effect of lag values will die out and relationship between current and lag values will be no more. This shows the series is stationary, and if beta is equal to 1, it means every lag value reflects in current value, and the effect will be consistent. This shows relationship exist between current and lag values will remain throughout the sample. This means that series is non-stationary. Here I repeat, if beta is equal to 1, it means series is non-stationary. And we can also say the series has a unit root. This unit root is because of beta is equal to 1. That's why when we test the stationary properties of any series, the test is called unit root test. So this is the explanation of unit root test. Now come back to our equation. If this is our equation, subtract, this is the small derivation of Decay and Fuller, subtract y t minus 1 on both sides. What will we get? Y t minus y t minus 1 is equal to, after simplification, b minus 1 y t minus 1 plus error term. This would be the equation. Now this yt, so this shows the difference d yt is equal to b minus 1 y t minus 1 plus error term. The explanation is same as we have discussed in the above description. If beta is equal to 1, it means the series has a unit root, it means series is non-stationary, and if beta is less than 1, it means series is stationary. So here, for more simplification, we can write this equation by putting C where C is equal to B minus 1. So this is the equation. This is the equation of Dickey and Fuller. When we apply the Dickey Fuller test in any software, we can see there are three options. This one would be none, because there is no intercept and there is no time trend. If we write this equation like this, A as a constant plus this one, this means this is Dickey Fuller equation with intercept. And if we write this equation like this, A plus W with time trend plus yt minus 1 plus error term, this Dickey and Fuller equation would be trend and intercept. After this, if we increase the model fitness by adding the lag value, of dependent variable, like this, d y t minus 1. This is the lag of delta yt or dyt plus error term. You can add lag 1, lag 2, lag 3 up to 1/4 of your sample size. So after adding this lag of dependent variable, the Dickey Fuller function will be Augmented Dickey Fuller. Now the equation is ADF, and when we apply the unit root test of ADF, unit root test of ADF, the null hypothesis H naught is series is not stationary. Series is not stationary if p value is greater than 0.05. This is the case when we consider the 5% level of significance. If p value is greater than 0.05, it means accept H naught, which shows series is non-stationary. On the other hand, if p value is less than 0.05, it means reject H naught, which shows series is stationary. Now how can we apply this ADF test? First you have to open your series like FDI. This is your series. Go to view, unit root test, and here you can see by default EViews set Augmented Dickey Fuller test. These are the three options. None means no constant, no time trend. This is the intercept, the equation with intercept only, and this is the trend and intercept. This is the equation with intercept and trend both. So if we select this, none, then okay. The hypothesis is series is non-stationary. You can see also here FDI has a unit root. Unit root means series is non-stationary, and the p-value here is 0.995, which is greater than 0.05, except h0, it means series is non-stationary. And here you can see the equation as well. This is the lag value and this is the dependent variable. Now view unit root test. If we apply the intercept, then okay. So the result also show here the value is greater than 0.05, which means except h0 the series is non-stationary, but you can see the equation included a constant term. And if we use trend and intercept, the result shows the series, the value is less than 0.05, it means reject h0, which shows this series is stationary. And you can see the equation including time trend and constant. So this is the stationary analysis and unit root test. I hope this video helps you to understand the concept of stationary, non-stationary series, including Dickey Fuller and Augmented Dickey Fuller test with the EViews application. If you like the video, please subscribe my channel TJ Academy.